Good day, guys. I'm Steve, your maths facilitator, and this is my YouTube channel, Maths Tutorials. Our topic for the day is about differentiation of a product. So we are saying that if y is equal to uv, where uv means u times what? V. And the u and v are functions of x. Then by the product rule, we can say that dy over dx, in other words, differentiating y with respect to x, is equal to u dv over dx plus v du over dx. So you hold u constant whilst you differentiate v, plus you hold v constant, you differentiate what? U with respect to x. And this is our product rule. So anytime you have a function to differentiate in which it is a product, you can apply the product rule in differentiating it. Okay, we are going to take few examples and explain further. Okay, so our first example is y is equal to 2x squared minus 1 multiplied by x squared plus 3. You can see this term is multiplying that, so it makes it becomes what? A product. Solution. Using the product rule, you can see that dy over dx is equal to u dv over dx plus v du over dx. This is a product rule. And you are going to say that let u stand for the first term and v stand for the second one term. So let u be equal to 2x squared minus 1 and v also be equal to the second term, which is what? S squared plus 3. From our product formula, we can see that we will need the v with respect to x, and we will also need the u with respect to what? Dx. So it means we need to differentiate u with respect to x and also differentiate v with respect to what? X. So du over dx will give us what? 4x, and dv over dx is equal to what? 2x. We've already learned about the rule of differentiation. So please, if you know you've not learned that one, please go to my channel. You will find Introduction to Differentiation. Please study it. Okay, having differentiated u with respect to x and v with respect to x, I can now substitute them back into the what? The product formula. So dy over dx is equal to u, and my u is what? 2x squared minus 1. Multiply by dv over dx, which is what? 2x plus v, and my v is what? S squared plus 3. Multiply by du over dx, and du over dx is what? 4x. So from here, I'll just expand. So dy over dx is equal to 2x times 2s squared is what? 4s cubed. In indices, when you're multiplying with the same base, you add the powers. So the power here is 1 and the power here is what? 2. 2 plus 1 is what? 3. When you are multiplying with the same what? Base. 2x times minus 1 is minus 2x. 4x times s squared will give me what? 4x cubed. Because there's a power of 1 here. The 1 plus the exponent 2 give me what? Exponent 3. Plus 4x times 3 is what? 12x. From here, I can group like terms. S cube, and S term and what? S term. So let's group like terms. Grouping of like terms. Y over the x is equal to 4s cube plus 4s cube minus 2x plus 12x. Therefore, dy over dx is equal to 4s cube plus 4s cube is what? 8s cube minus 2x plus 12x is what? Positive 10x. And this will be our final answer. So this is how we apply the product formula in solving such expressions. Now, there is also an alternate way of solving this. Someone can decide not to use the product rule, and he or she will expand, and after expanding, you will differentiate. You also arrive at the same answer. So you can expand this, and after expanding, you differentiate your answer. So y is equal to, let's expand this, 2s squared will multiply s squared plus 3, and the minus 1 will also multiply what? S squared plus 3. 2s squared plus s squared is what? You get 2x exponent 4. 2s squared times 3 is what? 6s squared. Minus 1 times s squared minus s squared. Minus 1 times 3 minus 3. Let's group like terms. Already the like terms have been grouped, s squared and s squared. So we have 2x exponent 4. 6s squared minus s squared is what? Positive 5s squared minus 3. Now let's take note of something here. You see that all this will have been written y. meaning I was just expanding and simplifying. But once I start writing dy over dx, it means I've started to differentiate. But all this while, I was writing y is equal to y is equal to y is equal to, meaning I was just expanding and simplifying. So I'm now going to differentiate, which is dy over dx is equal to. Now when we differentiate 2x exponent 4, what do we get? 8x exponent 3. When we differentiate 5x squared, what do we get? 10x. When we differentiate minus 3, you get what? 0. Because when we differentiate a constant, you get what? 0. When we differentiate 1 is a constant, we will get 0. When we differentiate 4 is what? A constant, you get what? 0. So when we differentiate minus 3, we get what? 0. And we will not write the 0. So you see that our answer is the same as using the product rule in solving it. So you can decide to expand, and after expanding, you differentiate. Or you can better still use the product rule in arriving at the same answer. Please, let's take our next example. We are to differentiate y is equal to x minus 3 multiplied by x squared plus 7x minus 1. We can see that this is multiplying this, so it makes it become what? A product. So we can use the product rule, or better still, we can expand, and after expanding, we differentiate. But I'm going to use the product rule, and you can also decide to expand, and after expanding, differentiate. So the product rule is giving us dy over dx is equal to u dv over dx plus v du over dx. So let u stand for this and v stand for the second term. So let u be equal to x minus 3 and v be equal to x squared plus 7x minus 1. In our product formula, we will need dv over dx, and we also need du over dy x. So it means we need to differentiate u with respect to x and differentiate v with respect to x, so that we can substitute them back into the product formula. So let's differentiate them. Du over dx. When you differentiate x, you get 1. When you differentiate negative 3, you get y 0, because the 3 is a constant. Now let's differentiate v with respect to x. When you differentiate x, we get 2x plus differentiate 7x, you get 7. When you differentiate minus 1, you get 0, because it's a constant. Now we are going to substitute them back into our product formula. dy over dx will be equal to u. My u is x minus 3 multiplied by dv over dx, and dv over dx is 2x plus 7 plus v. This is my v, x squared plus 7x minus 1 multiplied by du over dx, and du over dx is 1. So times 1. dy over dx will be equal to, we need to expand this. X times 2x is what? 2x squared. X times 7, 7x. Negative 3 times 2x, negative 6x. Negative 3 times 7, negative 21. 1 times whatever is in this bracket will give us the same result. So we will get plus x squared plus 7x minus 1. So we will just group like terms, grouping of like terms. Dy over dx will be equal to 2x squared plus what? X squared plus 7x minus 6x plus 7x minus 21 minus 1. So dy over dx is equal to 2x squared plus x squared is what? 3x squared. 7x minus 6x will give us x. X plus 7x is 8x. Negative 21, negative 1 will give me negative 22. And that will be our final answer. Our third example. In this example, you can see that x exponent negative 1 is multiplying whatever is in the bracket. So we can use the product rule. But for clarification's sake, I'm going to use the other method whereby I will expand and differentiate. So your assignment is for you to use the product rule in arriving at the same answer. So let's expand. X exponent minus 1 times 3 is what? 3x exponent minus 1. X exponent minus 1 times 4x will give me what? 4x exponent. You see that there's power 1 here. Sorry. There is power 1 here. And this one too is what? Minus 1. So when you're multiplying, you add their powers, which will give us this minus 1 plus what? 1 plus x exponent minus 1 times 5x exponent 2 will give us 5x. This is power 1. Sorry, power of minus 1 plus this power of 2. So in indices, whenever you're multiplying with the same base, you add their powers. So I'll add the power of minus 1 plus what? 2. And that's what we are having here. Y is equal to 3x minus 1 plus 4x minus 1 plus 1 is what? 0 plus 5x minus 1 plus 2 minus 1. So we have y is equal to 3x exponent minus 1 plus x exponent 0 is 1. And the number raised to the power 0 is what? 1. 1 times 4 is 4 plus 5. Sorry, here is positive 1. Minus 1 plus 2 is positive 1. So we have x. Now, We finish expanding and we can now what? Differentiate. So all these three steps were just expansion. So that's why you're not seeing the dy over dx there. You are just seeing the y, meaning I was just expanding and simplifying it. So having done that, I can now differentiate dy over dx is equal to negative 1 times 3 will give me negative 3x. Then I'll subtract 1 again from the power, which will give me minus 2. Rule of differentiation. When you differentiate a constant, you get what? 0. So plus 0 plus, I'll differentiate 5x, I'll get what? 5. So in turn, therefore, dy over dx will give us, then let's take the reciprocal of this, which will give us negative 3 over x exponent positive 2. The reciprocal of the negative 2 exponent 2 will tend to become what? Positive what? 2 plus 5. And that would be our final answer. So please, you also try it by using the product rule and see whether you arrive at the same answer. And you should get the same answer. You should get the same answer. So these are our 3 examples for the day. I'm going to give you some try questions so that in our next meeting, you all look at the solutions. Please try your hands on these 4 questions, and in our next meeting, we'll look at the solutions before we continue. Thank you very much for your attention, and please do subscribe to my channel and keep practicing more on this. Until then, bye for now.